So a lot of people have been asking me about serial data or data buses and how to figure out how to find what computer is not talking or not communicating with the system. Main thing is you got to figure out what computers are actually not communicating. When you go through your code scan, you'll see a U code, and it usually gives you that information, say like instrument cluster. Then you can just follow the instrument cluster data line. So we can see that we see the serial data gateway module, which goes to your splice connector. Now your splice connector it's like little shark teeth, and it ends up making all these connections through the data connector. Now, a data connector kind of looks like something like this. A lot of them don't have the diodes in it like this or a fuse. They're just a piece of metal and a plastic which hooks all the wires together to make everything one unit. So when testing this data line, we have our regular scope pattern on regular ground, and then we're going to have our test lead going into the splice connector. I like the splice connector because it puts all the modules together. So the main thing is we got to find what pattern looks like this when we disconnect the splice connector. So once we find a pattern that looks like this here on the bottom, this one, once we find it here, then we're going to take a wire and we're going to jump each wire, and as long as this doesn't short out, then the splice connector that we go or the computers are good. Once we go to a wire and it looks like the pattern here where the red is, the arrow, that means that that computer is shorted out. And then we have to follow that wire to wherever it goes. On this one, it ended up being the audio amplifier, so I just highlighted the audio amplifier where it goes. Then we disconnect the audio amplifier, come back to our splice connector, put our splice back in, and then see if we have our signal like we see down here on our bus signal. If we have all this going to here, then the data line would come to here and then go back to your OBD, and you should be able to communicate with all the other ones. So just remember that when one of these computers shorts out, it shorts out 90% of these modules to where you can't communicate. And then this is an easy way to tell what modules bad or what modules shorted out. This one, and now I have a video and then actually how we did it live through this video, and hopefully this will help you guys out in the long run. So welcome back. This is a live where I was on a person's scanner helping him out on a specific problem that he had with the instrument cluster. The instrument cluster wouldn't work, so we knew that there was a network problem, and we had to figure out what network problem. Just like before, once we figure out which network is the issue, because you have many CAN bus systems, you have your high, your lows, your positive, your negative, where you have to hook your negative and positive lead to that CAN bus. But we only have this G-line, this simple G-line bus that goes in. So the first thing you want to do is like what we're doing here is let's go ahead and just scan all the modules. Now, when we got done with this module, we only had like 16 or 17 computers in it. Well, the thing probably holds, 20 something computers. So we knew that we had lost the instrument panel, lost the radio, lost the amplifier. So at this point, I kind of knew where I had to go with this CAN bus system. Like before, when I was reading on the schematic and showing you on the schematic, we have to figure out which ones we have to communicate first with. So once I saw that we lost communications to the radios and the instrument clusters and the amplifiers and modules, stuff like that, I looked at the schematic, and then that's when you can see the G-line bus that feeds all these other computers. So we go to that splice pack. So once we get a splice pack, we knew where we had to go with the scope. So these are the most common, like I say, your splice connectors. The Chrysler one is usually behind the glove box. You'll see about 2 or 3 of them there. You can go right to that. I've seen them on to the left of the steering column, back behind the panel, which usually goes to the door modules and stuff like this. So on the left side, this is where the splice connector is. You disconnect it. You can see a good scope pattern on the left side. So the one is disconnected. Find a lead that has that scope pattern with it. Then you go to number 2. You connect one wire that has that good scope pattern, and you keep it on that scope pattern, and you go from wire to wire. You can see here we have a good scope pattern, and then we're going to start jumping the wires over. So once we see I have it pinned out to that pin that usually goes through the CAN bus network system, I have it pinned out, and then now I'm going to take it, and then I am just going to jump from one wire that has the good, and then I'm going to go to A, B, C, D, E, F, G, and so on. You can see now that we have this shorted data bus. So now we got to figure out, okay, what number was that? Was that ABC? So you look on your splice pack, you can see where it has all the letters on it. Most of them do. You find the letter that we just went to that had the shorted out data bus, and we follow that to where that module is feeding to. So once we figure the numbers, it's easier. So now we just go to that data, which is J, and then J will go to a certain bus. And once we find that certain bus, we go to it. Pause. Now that we figured out what bus line it is or what letter it is, we're just going to highlight it. We'll go to the next screen, which is where it's going to show us where it's at. And then you can see that it will be the stereo amplifier. So when you change the stereo amplifier, just remember it does need to be programmed. You have to use SPS AC Delco website to program it. And I hope that this, guys, will help you. Now we're going to go back and then do another code scan on this vehicle. Once we do the code scan, it's going to go through everything, and then we're going to see how many modules we see now, which will be probably in the 20, 21, 22 range. And then that will tell us a lot of times you have to mess with the splice. Sometimes the connector doesn't get all the way in. And then also sometimes you have to do a cold restart. Just disconnect the battery, let it sit for 5 minutes, and then reconnect it. And then you should be good and everything should work for you. Here's a picture of the schematic again. I hope you guys like this. I hope this helps you out in the long run. Just remember to keep practicing it, and eventually it becomes a lot easier. So if you have any questions, just go to our atrguide.com, fill out a support ticket, and we'll help you out any way we can. Thank you. I want to thank you for watching this YouTube. Please hit the like button and subscribe, and hit the bell for notification. Thanks.